Today, a short introduction about myself. I'm a faculty member here in CEU Business School. My name is Paul Lacourbe. I will be the local host today. In fact, my boss is somewhere in New York attending a Board of Trustees meeting. So normally he plays the local host, but I take this responsibility today. As you know, CEU Business School launched an incubator some months ago, thanks to a generous grant from Mr. George Soros. We are cooperating with the many leading institutions in Budapest in different areas, including BNE, Semmelweis, Mohaly-Nagy. So one of the areas of interest for us is the life science. So we know that when humans have money, they want to spend it on themselves to live longer, to live better, and look better. So apparently this area has a lot of potential, especially when human beings are living longer and longer. Unfortunately, we are a business school. We don't have we don't have much in-house expertise in this area. Therefore, we joined our effort with the Semmelweis Innovation Center, directed by Dr. Zsombor. He will be the main moderator for today's event. So I'm just a local host. I set the stage, but the main actors are not me, but rather three experts from the medical field: Attila, Peter Grossman, and Zsombor. So now I will give the stage to Zsombor, who will be the main moderator for today's event. Okay, thank you.
Thank you, Paul, for inviting us here. So I will just briefly summarize. What we will talk about. The idea is that we will have three speakers, and the first speaker will be myself. I will give a brief overview of the biotechnology sector and the opportunities there, and a little bit about how to start a business in biotechnology, because it's not as evident as in other fields. And then my colleague Attila Bérces will talk about how to grow a business from the idea, so using several rounds of investment, to a point where it creates value, it is on the market, and it is working. And then we turn over the stage to Peter Grossman, who is leading a growing and actively expanding Hungarian healthcare provider company, and he will talk about business model innovations and the ways how he's expanding his business. So I will just start about this thing, and I will try to tell you why I believe that biotechnology is really a growing sector in the world as a business, and why it is worthwhile to take, or at least to try to get a slice of it. So I will talk about the problem, because I think most of you have already figured out, or yet read it in the news, that the big pharmacological companies are in big trouble now, and because they cannot deliver anymore. So there is a serious problem with their business model, and this is affecting all of the healthcare industry. So then there is a solution, at least one solution is venture creation and small biotech business models, and I will show you a nice example of that. And then, of course, if you are doing new business models, creating new ventures, then you may need new skills, and this may be obtained through bio-entrepreneurship training program, and this is where the connection point with CEU and Semmelweis innovation lies. So this is my favorite figure. Basically, the red graph is the number of new drug entities entering the market in the United States. So basically, this graph shows that in every year, starting from 1950, somewhere between 10 and 30 new drugs are coming on the market. And there was a beautiful, nice boom in 1996. So everybody was extremely enthusiastic at that time because all of these new molecular entities are going up. This is the time when, you may remember, the Human Genome Project was launched, and it was said that in 10 years we will, the number of new drugs will multiply at least by 10 times and such. And this is what happened. There came a sharp decline in new molecular entities. Just in the year when the Human Genome Project finished, and then we're supposed to identify lots of new drug targets, we didn't find any. So it is a big problem for all of the world. So how do big pharma react to that? They are using the textbook solution that if they are making a lot of money from patented drugs, and they have fewer and fewer patented drugs, then they have to generate more, right? So they doubled and doubled the spending on research and development, and you can see that the number, the volume of R&D cost is sharply increasing, and this graph is going until 2002. So they are, it seemed at that time that this model didn't really work. But there were still hopes in it. But I just gathered the very newest figure. So this is from the Berry report in 2012, and it still doesn't work. So there must be something very, very serious problem here. And you can already see the serious problems, like the biggest big pharma, Pfizer, has already just started to downsize itself. Pfizer itself is roughly comparable to Hungary in terms of business size, and Pfizer was the company where everybody wanted to work. They were the most innovative. They were coming out with Lipitor. They were coming out with Viagra. So I mean, this was a good company, still a good company. They have very profitable businesses, and they started to just chop themselves up. And it's very strange because they already started that they are making radical shift, and they are getting smaller. And they are not getting smaller, but laying off people, but they are getting smaller. But then by creating smaller companies from themselves and just selling them off, they try to focus. And of course, you can see lots of management discussions on the forums about this. But the point is here is that big pharma is not delivering anymore, and now they acknowledged it finally. Pfizer changed its name to Pfizer Pharmaceuticals to Pfizer Biotechnology a couple of years ago, but it was just a facelift. Now they are doing it seriously. So I will just show you a very nice example of a small pharma company, a very, very small pharma company. When its heyday, the company employed 9 people. And a friend of ours has started it, a professor in clinical pharmacology in Sweden, and they had a fairly easy idea. They were just producing a single drug, one drug. And it was not very complicated, it was hydrocortisone. Everybody knows hydrocortisone, even ones who are not in this business. That's a very old drug, I mean more than 50 years old. So what did they do? They had a very easy invention. They figured out that the natural daily cycle of hydrocortisone in the body has 2 peaks. But if you're just taking medicines, it's not really easy to mimic this natural thing. And there are people out there, patients, who need to take hydrocortisone pills for all of their lives. So for them, and hydrocortisone has lots of side effects. And they already figured out that this tricky thing, like this natural diurnal rhythm of hydrocortisone, if you can mimic it, you can decrease the side effects dramatically. So they were able to patent this thing, like this diurnal rhythm, and then they acted on it and tried to make a new company. And the new company just created this double layer drug. It had a core and it had a coating. Both of them contained hydrocortisone, and both of them were releasing hydrocortisone, but at different levels. So you can say that this is a fairly simple innovation. This is a kind of innovation Pfizer wouldn't touch, ever. Probably because it's very simple. It's using an old drug, which probably they are producing, and it's definitely produced cheaper by generic producers in China and India. So they wouldn't do anything with hydrocortisone. They wouldn't even spend a single dollar from their huge R&D budget on a project like that. But the small pharma company, 2 people at the time, has just started it. They didn't have money. So much that the 3 of them, the 3 inventors, just had to experiment on themselves in order to get through approval, because they figured out that because if you want to make a safety study, like testing it on human volunteers, you need to get ethical committee approval and you need to get a clinical trial approval. And it's very expensive, just getting all the paperwork and everything sorted. But nobody is just inhibiting you to do the experiments on yourself. So that's what they did. And they just did the experiments on themselves. They were taking the pill for several months. They were taking blood samples, measuring it, and submitted it to EMA, the European Medicines Authority. And they accepted it. And from then on, they were able to raise some venture capital and go for phase 2 trials, of course not on themselves at that time. And in the end, in 2011, they were able to receive a marketing approval for this drug. So what happened? They called it Plan-on-Dren. This was the first innovation in 50 years in this adrenal cortical failure, the disease which they are targeting. This is the first Swedish original drug since 2006. Now, Sweden has a large pharma cluster, and since in the last 5-6 years, they haven't produced any new drug, just this one. So they get the marketing authorization, and already at that time, 2 pharma companies were bidding for them. So they get a very good price for this company. At the date of marketing authorization, they received a 25 million euro down payment for the company and roughly 100 million euro milestone payments are in the line. So how much is it worth? And this is just a picture of or the cover of one of the daily newspapers in Sweden, and you can say that Saab, a company which everybody knows, has a very, very nice big picture because there was some, I don't speak Swedish, but there was some management change in Saab, and this was a big news at the time. And this dual-cord company also get a very small mention on the cover of the magazine. But when you compare the prices of the two, because Saab is also a Göteborg-based company, and just like dual-cord, they were sold at the same time, end of last year. But dual-cord received 20 million euro more, a company of 9 employees, and a single drug, and no sales whatsoever. So I believe that this is a beautiful example that biotechnology is a big business, it is a growing business. It's not really easy to compare it like the automotive industry, because of course I picked the nicest figure to compare. But still, it is out there, and it's possible, and it's really a possibility to make money out of it. But the real question is how? Because if you believe that this is the next big thing, you should understand how it works, you should understand how the technology works, and then go for it. And I believe that bioentrepreneurship training is more or less the only way that we can increase the volume. Why? Because there is a bottleneck in starting new companies. I believe that it's safe to say that we have reasonably good research output. We meaning we in Budapest, we at Semmelweis University, we in Europe, we in the world, we everybody else. So I think we generate a hell of a lot of knowledge. We are publishing so many papers in so many journals, you can't even keep track of it. So there is very, very good research output. It's quite complicated. I myself cannot understand 99% of what they say about new technologies, but at least we can grab part of it. We have the necessary legal framework, at least in the developed world. You can easily start a company, you can license technologies in. From 1980, there is the Bayh-Dole Act in the United States, which pushes the universities to sell their knowledge. We have the legal framework. We even have grants to support it. We have investors, we have soft funding. Just 2 years ago, 40% of the VC investments in the United States were going into biotechnology and life sciences innovations. So money is there. So there is money, there is knowledge, there is the legal framework, everybody is there. We don't have enough projects. So if you're talking to investors like I do, and they always complain, we don't have enough projects, we don't have enough projects, please bring us some more. And I cannot. I really can't bring them enough nice, good projects. because we have the technology, we have the legal framework, we have the funding, but we don't have the people to run these companies. It's simply very complicated to find a person who can just do these things. I mean, luckily we have at least 2 colleagues who are doing it. So who is doing what? Why is this human resources problem here? There is a scientist. I am a scientist. I am a medical doctor, and I am also leading a research lab. So I am reading papers, scientific papers. I create new results, doing experiments, getting the data, analyze it, and then I publish it, and then I read more papers. This is roughly the life cycle of scientists. Reading, experimenting, writing. Reading, experimenting, writing. That's just about it. And you do it 60 hours a week. There's not much else, not much time left to do. So what is a manager doing? A manager is running a business. Raises some money, spends the money, maybe increases the business a little bit, and then raises some more money. So a very good manager, a manager which is coming out from your school, can really work with a business which he knows and understands, like a print shop. You know, he knows what it does, he just needs to run the people. It's a lot of work. I mean, it's 60 hours a week. That's okay. So we are missing somebody here, the inventor. I mean, everybody has seen inventors. They come up with a great idea. They are trying to sell it. They are trying to sell it. They sell it to everybody, selling it to us at the university, selling it to investors out there. Nobody wants to buy it. They are getting a bit frustrated, a lot frustrated, and then they come up with a new idea. These are the typical crazy inventors. And they are just not in the movies. You can see them everywhere. If you're a scientist, there won't be much of a biotechnology business. If you have only managers, you won't have much of a biotech business. If you have inventors, you definitely don't have any biotechnology. So what you really need is a person who is a 3-in-1. So a person who can understand new papers, I mean, read the scientific papers, understand it, even create the new results, but not in a way to create more and more papers, but in a way a manager uses it. So just a kind of a scientist who can turn his results into a manageable way, and they have to do it in an innovative way. And these are the people which are not easy to develop. So we at Semmelweis Innovations has just designed a program targeted to these new entrepreneurs. And our idea, or our approach there is that we do teamwork. We do teamwork at real businesses, not just case studies. Because I have shown you one company, but you can see many, many examples which tried the same thing and it didn't work. So it's much better and much easier to get your experience and knowledge, not from case studies, but from real businesses. I mean, you are getting your hands dirty, you are spending some real money where it really hurts, and then you will experience more. We are using private consulting and coaching because there aren't really good textbooks in this field. Maybe 10, 15 years time there will be, and Paul is just sitting down and writing it. But there is a minimum contact time. I mean, I mentioned that if you are a good scientist, you are already working 50, 60 hours a week. So if you want to participate in this program or any program like that, you have to minimize the contact time spent at the school. So that's what we did. And of course, we are doing it in an international way. This is a 3-semester program. I don't really go into the details. You can get more information on the web if you are interested, or you can get back to me. So what do you get when you come to us? We are trying to teach a little bit of hard skills, not too many. Because if you are coming from the business world, it's impossible to teach you in 3 short semesters exactly everything about proteomics, genomics, biotechnology, and everything. It's just impossible, but you don't need it. You just learn the language, you just learn the business ideas, you just learn how to handle scientists, and that should be enough. Same thing for people, for scientists. I mean, if you already have a PhD, if you want to get management skills, you have to pick up an MBA program. But if you're coming to us, just simply learn how to talk to other people and how to work in a team, which is, I think, is the most important thing, soft skills. How to assess yourself, your team, and how to negotiate it with your employer, with your university, with your teammates, with your investors. I think this is the key. Of course, you need a professional network, but the good point is that if you are good, even within this program, you can even start a company. And that happened, and several times. So if during this training program you already start a company, then you can cooperate with CEU Innovations Lab, which has just started, and then we already started to figure out the framework how we can cooperate together in this field. That would be a very, very good starting point, I think, for a biotechnology company in Hungary. So what are the results of training? We are with an earlier type of training, which is quite similar to what we do now. We just measured what happened to the alumni. And the idea was just to call everybody, and we had a control group. I mean, we are scientists, so we like to have a controlled experiment, and we had a control group, which was the same cohort of people who applied. They got through 4 series of interviews and admission assessment centers, but then in the last round, they either dropped out, and it just didn't work for us for any reason. And it's a good thing that most of them had a job. So no matter what people, so they were talented people, they were employed. The funny thing was that those who participated in that hands-on program, and they got all of the frustration and all of the problems which are coming from working with real scientists and trying to make some sense out of their ideas, 10% already got into leadership positions at different companies, but 1/4 of them started a company. Maybe not from what they learned at the school, but they just picked up another idea, probably a better one, and they started a company. And these guys are successful. They are all around us. A few of them are here. So I believe that this is the most important point in any of these trainings. So this is what I wanted to say, and I would like to ask Attila Bérces to talk about his experiences with his startup company.
We should have a 5 minutes Q&A. Do you have any questions for? Yes, Hector.
I'm a filmmaker, and I'm okay in math, but I'm just curious if you're going to put 3 people into one, and each of them is working 60 hours a week. That comes up to 180 hours a week, right? Right? Yeah. So I'm just curious, should it be maybe 1.5 and 1.5, or 2 and 1? I mean, are you really trying to make a superhuman?
Not really. Not
Okay.
really. The point is that, especially in this, during this program, people are working in teams of 3 or 4, sometimes even 5. So everybody has a responsibility. For example, if you are a scientist, you are a PhD, you don't have to write the cash flow Excel sheets, but you have to provide the data to the person who has better management skills in the team, so they can work with you and just fill out the cash flow sheet. And you have to understand it as a scientist. That's the point, and vice versa.
Any other questions?
So the same slide, so isn't the scientist and the inventor pretty much the same person, or what's the main difference in that case? So you have scientist, manager, and an inventor, but most likely the scientist is also the inventor, right?
Of course, it's an oversimplification, but in reality, if you are talking to scientists, they don't like inventions. I am talking to lots of scientists, and I don't like their attitude, because their attitude is that my job is to generate knowledge, publish it, and it's somebody else's job to create innovations, to make inventions from it.
But
they don't like to do it. They are trained not to innovate. That's the problem. Because from the outside, that's a valid question. But from the inside, it's not motivating for them. And they are not incentivized to do that either.
I see. One question, Lacza.
How does a manager know that an invention is brilliant and has added value?
They don't.
So what do you do about it?
That's why a manager or a businessman has to learn the business models, has to learn something about biotechnology. So not really the molecules themselves, but how the sector works. That's why we have this school. So that's the point. Just to understand, try working together, then you will be able to read the knowledge, you can just pick up the trends, and then you can apply experts to help you out with that. But that's not easy.
I would be really curious about the background of the applicant. So where are they from business or from the medical sciences, and what kind of experiences do you have? Who is your typical applicant?
There is no typical applicant. We just require a person to have a diploma and to have a strong motivation to learn something in this field. And that's just it. We really want mixed teams because that's the only way it works. So roughly half of them are coming from the business field, but some are coming from law or even arts and sciences, and other people are coming from the medical field or technology or engineering. And that's the point, just to keep it mixed.
Yeah, we would like to pick up on this question, how do you know? And you don't, but this is exactly the art of entrepreneurship, to actually find out from the lowest possible, using the smallest possible resources, which idea will be worth developing into a big business. And this is the difficult thing. And this is what the pharmaceutical industry is struggling with, because it costs them $1 billion to learn that a potential therapy is a real opportunity or not. So, but this is true for any kind of business, that there will be many dead-end streets and many false opportunities. And without trying them, we don't know. But we must somehow minimize the resources, finding out that that idea doesn't work.
Coming back to the innovators, who would be an innovator? Is it a type of a scientist? Just is it a skill or a talent that the scientist has, or is it who is the innovator?
Myself. So I think it's all going down to incentives and motivations. Scientist is really a person, I mean the person with a PhD, who understands how the things work. They can do the experiments, read the literature, have the knowledge to do things. And if they are incentivized and motivated to come up with inventions, then they will do. If they are not incentivized, they are incentivized to go back to the university and teach as many students as they can, plus write a few papers. That's what they will do. So, so basically being an inventor is in everybody. I think we experienced, I don't know how many projects, more than 200 in the last 5 years at Semmelweis Innovations. And during these years, basically everybody from our own team came up with an invention. So we all signed up for each other's courses. And we all have our own inventions working there. Because, just having the motivation and having the nice, seeing the opportunity, you will come up with ideas. There's no shortage of ideas.
Actually, I have a follow-up comment because I have seen a similar pattern in business schools as well. Like I'm not from the medical field, but we have many professors in the business field, like operations management, production management. The differences between scientists and inventors also exist in my own field. So I have colleagues who read papers, write papers, and that's the only thing they do. And there is a small minority, actually such as myself. I would like to think, I always ask my question, okay, this is nice theory, this is nice paper, okay, can you make money from this paper? And so actually I do ask this question. I go and observe why many companies in Hungary are not efficient. I think, can I take 1 paper, 2 papers from Harvard Business Review and change the company for better? And I think that it's not exactly the same field, but the logic is similar, that if you read the papers and you see something in reality that is not working, can I use your knowledge and create value for real business? I think that's the difference between a scientist and an inventor that also exists in the business school, in the business world.
And, I can give you an example. For example, like I just collected my thesis for anyway, and 27 scientific papers are put together into that thesis. And only 3 of them, which formed one project, which were good enough or interesting enough to become an invention. They were not the most cited ones, not the most important ones from scientific terms, but from then on, we created 2 patents, and then we sold the project to a pharmaceutical company. So roughly 1/10 of the science which I generated during these years were suitable enough for a business approach.
So you mentioned the Vital Act. Is there anything similar here in Hungary that would provide the opportunity to public universities, research institutes to acquire ownership in IP rights? And related to that, in your experience, what's the landscape insofar as public-private partnerships in the bio area?
Yes, there is an act. This is called the Innovation Act of 2005. This is a very innovative act. The problem is that the government is just not really going along with its own laws. They have just closed this week anyway, we can go into more details later, but anyway, there is an act, and this is okay for the universities to sell their knowledge, and their technology transfer offices set up at every university. So the legal framework is there. There aren't too many people who are just using it, but it's there. Okay, I think it's time to move on. Attila, please.
Can we turn off the projector for a second? Sure. So, ladies and gentlemen, it is my pleasure to be here, and I will not be using slides. I thought that the best thing I do is I teach you 3 of the important things that I learned, and I tell you these are things that I learned in sort of a classroom setting, and something that was very useful in practical business in the biotech area. And the 3 things are, one of them is the art of being first. The second one is that this type of business always has 2 dimensions, and one is the technology side, the other is the business model side. And the third one is that you do not have to be 25 to hit your first $1 billion, and it is especially true in the biotech field. So in terms of for those who are students and want to plan their life, there are some lessons there as well. So coming back to the first one, what I will do, I will ask you some questions, and those who know the answer, just shout out loud, you know what the answer is, and the person who will be first will get a LinkedIn recommendation from me after the course. There are 4 questions, so if you get 3 of them, you will get a LinkedIn recommendation. Virtual cookie. So first question is, who were the first people to fly controlled powered flight?
Right, brother.
Yes. So then the next question is, who was the first to fly solo across the Atlantic? Yes. And who was the first astronaut?
Yuri Gagarin.
Yes. And the fourth one, who was the first man on the moon?
Armstrong.
Yes.
3.
You will get your virtual cookie. So, okay, next question. Who was the second person to fly? Fly controlled flight.
The Wright brothers.
Second.
Who was the second to fly across the ocean, the Atlantic solo? Who was the second astronaut?
Aldrin.
Who was the second man on the moon? There wasn't. So there is a very important story here. Everybody remembers the first. The second one, well, we remember the second one if they were first in something, because maybe they were the first American, or you know, there might be some other reasons, but we remember only if they are first. And for any organization to exist, they must be first in something, in the minds of their customers. Even the grocery store on the corner must be first in the customers who live nearby, because it is local, because it has the goods they need. So they must be first. Now, in the biotech field, it's extremely global. It is exactly the same thing. If you start up a biotech or any kind of technology company, your company must be first in the customer's mind for one reason. And this was a very important lesson for me. And I will go on to the second part of the lesson to actually tell you a little bit about, you know, how we can be first still in this globalized world. And the second lesson is comes actually from Søren Hjølander in Gothenburg at the International it's not the Bioscience Business School, it's the business school at the Chalmers University. And he studied various startup companies, technology startup companies, and created a framework for explaining the success of these companies. And he used the learning model. He said that any business is really a learning experience. And people learn in different ways. And people have different learning preferences. And these learning preferences affect, actually, how successful that business can be. And Søren said that this learning in a technology-based business has two dimensions. One of them is the technology itself. The other is the business model. And we have different ways to learn, both of them. And in order to explain these differences, we can go back to Jung's theory of different kind of personality, and you may know a little bit about that, in terms of lifestyle, in terms of preferred lifestyle, there are two different kind of people. One who prefers a more structured life, and one who prefers more spontaneous life. And those people who prefer more structured life, they also prefer more structured way of learning. And actually, Jung calls them the judging people, so let's call them J. Those who prefer more spontaneous type of learning, they are the perceivers, so let's call them P. And these are the people who like to experiment with things. So they don't methodically plan the way they are going to go ahead in their learning, but they experiment with many different technologies, often unrelated technologies, often with the goal of solving a particular problem. And we can learn both the technology and the business in the structured way and the experimental, more experimental, unstructured way. And the interesting thing that Sarah Hjolander found, based on studying some of the startup companies, that those companies who fall into this category, that in their technological learning and business model learning, they are extremely structured, they are usually a failure or failed to grow as successfully as the rest of the companies. And also those companies who had a very unstructured way of approaching both the business model and the technology, jumped from one technology to another and approached a totally different market in the next day, they were also a failure. And those who had a mixture of the structured technological learning mixed with an experimental model, business model learning, these were successful. And again, those that mixed the experimental learning with the structured business model, these were again successful. And if you think about it, it makes perfect sense, because these companies here who are experimental in their business model, experimental in their technology, they just don't know what they are doing. They are totally totally out of control, out of hand. Now those companies that fall into this category, very, very methodical. The problem is that they could not make that improvement in their processes that is really needed to have an edge, who really, really become successful, really grow much faster than the competition. Those companies that fall into this category, this is a very interesting one. It's J in terms of business, very structured. So it means that they already know what problem, what business problem they are going to solve. They may not know exactly, who are the actors, they may not know the channel, but they say, well, these are the things that we are going to try out. But for that particular business problem, we are going to experiment with many, many different technologies, and we are going to find the best technology to solve that business problem. They are usually successful. Obviously, they have to find the good technological solution. Now, if we look at the companies here, and in terms of technology, they are working in a particular field where they are very, very methodical in terms of their technology development. They are experts in their own field and develop systematically that technology, but they don't know exactly what's going to be the business model that's going to make it successful, and then they decide, well, let's try out different business models. They can also be successful. And this is very true to what we have been doing at my company, and also not just in the company, but since the very, very first time I thought about starting up a company on the basis of a technology. And in order to find the right team, the right company structure, it is also very important to have a team that has diverse personalities. And when I put together my own team, I I always wanted to have a diverse team, because I knew that it was very, very important that I don't have the replicas of myself in the company. And obviously it is difficult to work with a diverse team. We debate all the time. We have heated debates. But that brings really the business forward, and we really have people who are more this type of learning style, prefer this type of learning style on the technology side, and people who have more this type of learning style on the business side. And in order to get this balance sorted out, it also took me a few years, but I think this was actually quite important to get to where we are right now. And now, the third lesson, and that is that you don't have to be 25 to hit your first billion. Now, I was listening to a very good interview, a set of interviews today on the Hungarian radio, Kossuth Radio, about entrepreneurship, and the founder of Prezi and a few other people. And one interesting thing that came up in that presentation, somebody was saying that in the US, the average age of the entrepreneurs who start up successful businesses is 39 years old. Obviously, everybody knows the Sergey Brins and the Zuckermans and others who hit their first billion by 25, but this is not the norm. And especially those who are in business school and have some life experience in technical field and learn business, it's a very, very important lesson that another statistics that I heard 20 years ago when I was still living in Canada, that the average technical experience for a startup company founder was 14 years in the technical field. So they spent 14 years in an industry to learn the industry, and that's when they started up their business. So I think this is very, very important, because in order to start up a successful business, you have to learn both the technology, or, well, it may not be a technology, it can also be any field of business, but there is a technical side to it, and there is a business model side to it. So you have to learn your industry, and you have to learn your business model, and it takes time. This learning actually takes time. Just to give you sort of an idea of what I do and how this came about. So I was in an environment, I was a scientist in Canada at the National Research Council, which was set up with the mission to do research that has economic activity at the end of, as a product. And as a scientist, we were trained to actually plan our research in such a way that there is an economic activity at the end. And I was there between 95 and 2000, and in the 90s, from these institutes, dozens of spin-off companies came, and $300 million VC money went into these companies, and most of these companies are still around, these technology companies, and they actually taught scientists how to think about projects that can be that can lead to successful businesses. And I was always interested in technology, and I was trained as a chemist. I was very interested in computer science. And I wanted to somehow marry the two and look at how some quantum leaps in the computer science can give us advantage to solve chemical problems. And the first thing I wanted to do is actually how to develop some new technologies that can help us to determine protein structures more accurately. Because protein structures are extremely important for drug discovery research, because most of the small molecule drugs actually interact with protein in the body. So understanding the three-dimensional physical structure is absolutely crucial. And it was in the 1990s when lots of VC money was around. And I talked to some VCs, and we started talking about how much does a protein structure cost. It's like $80,000. How many genes we have in the human genome? That was thought to be 100,000. How many variants that can be? Well, each could have at least 100 important variants. You multiply all these numbers together and you have an astronomical number which is larger than the GDP of the United States. And you have a VC who says, wow, this is a huge business opportunity. And unfortunately, in 1990s, all the VCs thought that the business potential was actually proportional to the number of genes in the human genome. Interestingly, when it turned out that the human genome had only 30% as many genes as many they thought, all these companies' share price dropped to lower than half. So, well, this was the environment when I wanted to start up my first business, and I talked to one VC that was actually very wise and gave me a very good advice, and said that, if what you are doing is important and you have an opportunity to go to work at a pharmaceutical company, which I did at that time, then you will be able to sell it internally, develop it internally, and spin it out. And it was actually Novartis, and Novartis at that time had like 200 spin-off companies within a short number of years. So I did that, and I got support for the company internally, and for political and all other reasons, I could never finish the project because I was recruited by another pharmaceutical company, and I couldn't really continue the work. But I was always fascinated by how we can improve the accuracy of those calculations that we do based on some novel technologies, novel computing technologies. And then the next thing I saw that, one day at AstraZeneca, they delivered a big container. And they set up a big container on our backyard. And I asked, what is this? And they said, well, this is our new supercomputer. So the problem was that it generated so much heat that they couldn't put it into a highly insulated, efficient, energy efficient building, because just simply it produced much more heat than it needed to heat the entire unit. So I thought, well, this is an opportunity to actually do something and use some new technologies and solve some problems. And then after this, I left AstraZeneca to start up the company. And this was the first thing that motivated me to start up a company. And then, interestingly enough, one big problem was that one is time frame, and the other is I wasn't able to put it exactly together with the business needs. I started out very much from the point of view of technology, and I only realized it retrospectively how incredibly huge problem we could have solved. And unfortunately, we did not realize it. But between 2002 and 2007, Pfizer, the largest pharmaceutical company, spent $1 billion on acquiring new chemical compounds. You can just imagine a huge storage where they have little vials and they have physically these compounds on the shelves, and they have robots, and these robots can take them out and make solutions for automated experiments. Now, they spent $1 billion, and the only problem was that half the compounds they bought, they were wasted. The problem was they didn't know which half. And we were developing technologies, and these technologies could have actually told which half they should have never bought. And this could have saved $100 million a year for Pfizer alone, and this could have saved billions of dollars for the entire industry. The problem was that at that time, I could not connect the technological opportunity with the business model, well, not even mentioning that I did not get funding early enough, and by the time in 2008 we had the solution, and in 2009 these companies hit the physical limits of their storage system. They couldn't buy anymore. And also the economic crisis hit, which made people think a little more rationally. And in 2009, Pfizer actually wrote off half of that $1 billion investment in the company. It was a financial write-off, and all that wasted compound could have been saved with this technology. But at that time, they didn't buy compounds anymore, so this technology was unfortunately not useful. However, at that time came a new opportunity, and the new opportunity was in the area of next generation sequencing and DNA sequencing, and this is the area where we are right now. And starting 2009, I started to tell, at that time, I met our first investors, and I started to tell them, listen, next generation sequencing in diagnostics is going to be a big business. It's going to be a huge opportunity, and we want to be there. We want to be there. And from 2009 onwards, we delivered new and new technologies for this market. And then what happened? Try to marry the best of both worlds, try to come up with very, very fancy technologies, try to come up with the most trendy things, cloud computing, and marry the two largest technology trends in biology and in computer science. Nobody cared. We went to a conference, nobody cared. But I told my investors, look, there's going to be a time, I know, when we can help people And it's very important that we can help people with the knowledge that we have and with next generation sequencing and with the mission that from my first thought of starting up a company, I wanted to have better protein structures. Now the difference is I want to have much more accurate DNA analysis. And why is it important? There are some genes in the human genome, in our genes, that determine, unfortunately, our fate in some of the deadliest diseases. And one interesting gene is related to breast cancer. And if there is a mutation in this gene, then women unfortunately have 82% chance of developing breast cancer in their life. So if these mutations are found at the age of 30, these women are faced with some very, very tough questions. For instance, preventive surgery. We cannot afford to make this kind of decision on data that contains errors. We must have the most accurate analysis possible. And this was our goal, to come out with the most accurate analysis in order to drive this part of the business, the diagnostics. But next generation sequencing wasn't adopted in diagnostics. It wasn't because these big machines, they cost $1 million and they cost $30,000 for a single run. They run for 10 days to 2 weeks. But I said, well, I told my investors, look, the time will come. The time will come. And in 2011, June 2011, one of these companies came up with a desktop solution for $55,000. Not $1 million anymore, $55,000. And one run, not $30,000, one run for $500. And they can do a few samples on this. And then this company planned to sell 250 by the year end. They sold 400 in the month of September alone. There's another company, a competing company, with a more expensive solution, a little more accurate solution. 40% of these new sequencers are going to molecular diagnostics labs. So the time has come. We introduced our product and we went to conferences until now and nobody cared, and we went to a conference to announce our new product for this market, for diagnostics, for these benchtop sequencers, and all of a sudden people were lining up at our booth and we couldn't stop talking to people. And we had our plan. We introduced this product last week. We had our plan to send out 8 demo versions by the end of this month. We sent out 9 in the first 10 days. So it's a very, very interesting story of the business model, learning the business model, and also learning the technology, and also believing in the mission and the vision. Our mission was that these accurate solutions will actually help people, help human health. And the vision was that this technology will be adopted for diagnostics. And now we see these things happening. But if you ask the question, could I have done this at 25? Absolutely no. you must have lots of technological knowledge on the one hand, and you must have lots of knowledge of business, which often means experience of business failure, experience of failed product, and learning from that. So it's very important that this kind of learning is very important, because we found our way to the market by methodically improving our technology, but in terms of the business model, even though people are still very interested in our product, I'm sure we are going to go through large iterations of what the best business model is going to be to make this really, really successful. And thank you very much.
Thank you. Thank you, Attila. If we have time for very, very brief questions, because time is running, and I just set up Peter's presentation on the board. Do you have any questions right now?
What exactly is your product? I don't think.
So our product is a software to analyze sequencing data.
And that data comes from a computer like this $55,000 computer?
Well, it is a machine that where you can put DNA samples in.
Okay. Oh, yours is?
No. The machine whose data we analyze. Okay. It's a DNA sequencer.
So have you partnered with that machine?
Yes and no.
Okay.
It's a more difficult question.
That matrix you drew, it's more relevant for product-based innovation, right, as opposed to services. For example, if I'm an internet startup, then can be argued that you need to change your service offering as well as your business model all the time, as opposed to a company which is building an invention or a product. In that case, it could be what you drew. So is it the same matrix for a services company as opposed to a product-based company, or is it different?
Probably it's different.
Is there anything to protect your intellectual property rights?
Yes, we do.
No more questions? All right. Hi, everybody. Let me first introduce myself. My name is Peter Grossman, and I am managing a company called Medcover. We are a private healthcare provider and a health insurance company. Do we have any clients of Medcover around?
Not yet.
One. Okay. Do we have any doctors around? Besides Zsombor. All right, so I have to be careful what I say. Now, when we put together this program, the idea was that we talk about startups first, and then I will be the one to talk about how we take a startup further. And the story of Medcover is that in 1996, when the company started, we had revenues about 1 million euros. This year we are shooting at revenues of around 300 million euros. So I would like to share a couple of thoughts how we got there, especially in terms of innovation. Now, if we didn't talk about innovation today, then my answer to this question would be actually very simple. I would say three things. One is it's about people. And for those of you who read Good to Great, who read it? Okay. Remember, you have to get the right people on the bus and the right people off the bus. This is a fantastic statement, and I must say I fully agree with that. Now, the second thing is that when we talk about strategy, we always need to be humble and keep in mind that, at least in my view, success is due to the right strategy, sure. but the weight of that is about 2 to 3%. And the remaining 97 to 98% is all about execution. So that would be my thought, but since we need to talk about innovation today, and innovation is strategy, so I will talk a little bit more about those 2 to 3% of strategy and what we have done in terms of innovation that may be interesting to you. And when I talk about innovation, this is going to be very different from what you have heard before. We have been an existing business. We are providing healthcare services. It's not about one single idea that scientists worked on for years and they believed in it. It's a lot about incremental innovation. And I categorize it in 3 categories. It's about processes innovation, product design innovation, and value chain innovation. Now this sounds very fancy, but you will see what this means. Before going into that, I'm aware we're running short of time, so it's okay. But I will be done in 5 to 10 minutes, and there will be room for questions. I would just like to introduce the company so that you understand what we are talking about. So we are a healthcare provider and health insurance company in Central and Eastern Europe, operating in Hungary, Czech Republic, Slovakia, Romania, and Poland. We primarily run healthcare centers, outpatient centers. We have 60 of them. We also run hospitals. We are running the largest private hospital in Poland. Another one in Poland, and another one that we just opened 2 months ago in Romania. We are the largest employer of medical staff. That is the largest private employer. Naturally, the Czech state is a bigger employer of doctors and nurses than we are. We do over 2 million medical examinations per year. This is just a couple of examples what we do. So this is the hospital in Warsaw that I just mentioned. This is one of our clinics in Budapest. It's actually close by. This is another clinic in Budapest located next to Nyugati Square. Some more pictures of that clinic. Now, of course, I will skip that part. We are very proud of our quality systems, and we are very proud that we get all these awards and distinctions. However, what we are the most proud of is how our customers rate us. If you ask our customers whether they would recommend these services to somebody else, 95% of them say yes. Now, of course, there are 2% who don't have an answer and 3% who say no, so you can always improve that ratio, but quality is something that is of utmost importance to us. Our business goes well because we have good quality, and people who come to our facilities come again, and they recommend it to others, and they recommend it to others again. So you may have the best marketing in the world, you may have the best sales people in the world, but actually drives this business is all about quality. So we have to be really quality maniacs. Now, before I make one point on innovation, I would like to ask this question. What do you think drives positive medical outcome? It's a fancy question the way it sounds stated here. What it means is, if you go to the doctor, if Paul goes to the doctor tomorrow and he has a cold, what do you think drives his chances of getting healed? Or if you have high blood pressure, what
first of all, it's also important attitude. If he believes that he will be able to be healthy, then that's
so your own attitude.
Yeah.
Prevention. Okay, but when you're actually sick, how would you maximize your chances of being healed?
Proper diagnosis.
Proper diagnosis. Okay. Is the doctor important? Good doctors? Okay. Who would say that good doctors are the most important thing? Okay. I disagree with you. And I will tell you why. And please let me not use my own words. There is a gentleman called Attila Bérces, who is something like a healthcare guru, and he wrote this great book. It's called the Checklist Manifesto. And he has 2 points in there. And let me share those in a simplified way. one is, as he puts it, on cowboys and pit crews. He says that healing people was a completely different business 50 years ago than it is today. Why? It is because of all the technological innovations. 50 years ago or 80 years ago, the spectrum of treatments and the spectrum of diagnoses that the doctor could choose from were really, really very limited. And therefore, it was locked down to how good the doctor was. And therefore, he calls this cowboys. And somehow we kept this as a reference point in our minds. Whereas today, as there's a lot more technology, there's a lot more interaction between different diagnoses, it becomes more and more important that medical professionals can work in teams. Okay, so when we recruit medical personnel, for example, doctors and nurses, of course they have to be the best in their field. However, what is at least as important as that is whether they can adequately work in teams. Now, the other point Atul Gawande makes is about checklists. And what he has actually done with the World Health Organization, the World Health Organization asked him to put together a checklist, a simple checklist, it is here, that operating staff has to go through in the operating theater before the intervention. Okay? I don't know if you can read it, but it's a question like, has the patient confirmed his, her identity, procedure, and consent? Yes. There is a question like, confirm all team members have introduced themselves by name and role. So, hi, I am Peter, I am the nurse. Hi, I am the surgeon, I am the anesthesiologist. And what they have done is they have selected a couple of hospitals around the world where they have introduced this checklist in America, in Africa, in Asia. And then they compared the medical outcome, the results of these procedures to hospitals in the same areas that did not use this checklist. Okay? It's as simple as that. And the outcome was there was a 30 to 40% improvement in outcome just because of this checklist. So this is what I call process innovation. And when we saw this, what we actually did at Medcover was we put together an electronic medical record. Actually, please have a guess. What do you think? How many, what percentage of hospitals in the United States today has electronic medical records versus how many use paper versions? 90%. It was up there, right? Very good. 20. Today, in America, only 20% of hospitals have proper EMR, electronic medical record. Okay? And what we have done at Medcover is we put together an electronic medical record that is also, it acts like a kind of checklist. So when a doctor puts in a diagnosis, the doctor has to go through a checklist. Your diagnosis is this. Okay, did you check this, 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 and this? Now, the doctor's opinion may be different from what is recommended through this checklist, but the doctor has to actively confirm whether he has answered these questions or not. And the doctor's opinion may differ, but then the doctor has to give his or her opinion why the opinion differs. Another example I would like to make is about telemedicine. There's a gentleman called Daniel Kraft, and he says that as many as 80% of the visits may be virtual. Only 20% of the visits are those where a real presence in the same room of the doctor and the patient is required. Now, we may or may not disagree with that, but there's a lot of potential in telemedicine. And most companies don't use it. We don't use it much. What we have started now is teleradiology. So we have digitalized radiological equipment, and the doctor who is looking at the results doesn't have to sit in the same room. It may be in one centralized room where they can access all the radiology results. Another example, and this is not just about the value chain, it's about the business model itself, it's medical tourism. Medical tourism is an exponentially growing business in different areas of the world, in Asia, in Thailand, in Mexico, and also in Europe. And what we have started is our hospital in Poland is now welcoming medical tourists for surgery from Scandinavia, from Western Europe. And in Hungary we have started dental tourism, so we have people coming from abroad for dental treatments. Yes?
Is the Delhi hospital belong to you?
No.
Okay. Because I have seen some tourism
Yeah.
there.
Yeah, same thing, yeah. All right. And then another interesting thing is changing a product design, putting together a different product design. So what we actually do is we operate outpatient centers at hospitals. Now, the basic business model is that somebody comes in and pays for a service, fee for service. Now we have put together a new product which is actually health insurance. It's a health benefit plan that we can sell to corporate client. It is about a lump sum that a person or a company pays for that person, and for that lump sum, the person has unlimited access to the services. It's the same service that we provide. However, it is put together a little bit differently, and it is hugely successful. If you look at our revenue model today, the vast majority of our revenues comes from health insurance. It is not fee-for-service sales anymore. Okay, and the last thought, and this is my last slide before concluding. We had this discussion, I was putting this together actually while Zsombor was speaking, about the profile of the adequate person, or the adequate profile of person that, of an entrepreneur or the people that we look for. And we have experienced that as the company grew, the profile of persons that we had to get into the business changed. I was just saying that companies started at 1 million revenues. We had a lot of entrepreneurial people. At one point, and this is when I also joined the organization, we were around, I guess, 40 million euros revenue. The company had to become a lot more structured. So we went out looking for people who had spent already an amount of their time working for big companies and had experience there. I happened to work for a big American pharma company in France. This is how I got to Medcover. And we recruited different other people with different backgrounds. And as we go forward, as the business grows and grows, we have realized that we need to get people on board who have very specific knowledge in very specific areas. So we didn't believe anymore in a model where you have these superheroes who can do anything. You know, the same guy is understands all about medicine. It's a great doctor. He's also a great marketeer and knows everything about operations. No. We went out to the marketplace and got in those capabilities and all that knowledge and all that innovation via people who understood a specific bit. So when we were looking for people to manage our clinics, we went out for people who had great customer service experience in a hotel or in other service business. As our call center was growing, we recruited in Hungary, for example, a lady who was managing a 1,000-person staff call center at Hungarian Telecom. When we wanted to increase business-to-business sales, we went out to industries that is a lot about business-to-business sales. Again, telecom and the like. When we were looking for marketing capabilities, we went out to industries that do have these marketing capabilities. And so on and so forth. So the learning here was that as the business changes and as your business grows, sorry, you have to look for different people. And so this is where my presentation ends. I'm actually getting back to my first statement, which was that the success of the business is really related to your people and how good your people are. Thank you. And open to answer any questions if you want. Yes.
You said you're the biggest in Central and Eastern Europe. I imagine that excludes Russia, correct?
Good question. We are not present in Russia. But as I know the Russian market, there is no, it is a fairly dispersed market. There is no one big player. So I do not think that there is a bigger player than us in Russia, but I'm not confident. We're not yet in Russia. We are in Ukraine now, going eastward slowly. We had made an attempt actually in Russia, and we burnt our fingers like 10, 15 years ago. Yes?
So what is your ownership portfolio? So who is owning you and how are you playing in the market?
Medcover used to, it is a Swedish founded company. It used to be quoted on the Stockholm Stock Exchange actually, and then the main owner of Medcover took it private. It is actually a wealthy Swedish family that owns the majority of Medcover shares.
And is it open for employees as well? So if you perform well, can you become a partner?
Well, we do have incentive programs.
It's not a question, it's a comment. I'm George Berger from the Business School. It's interesting to see how classical Fordian solutions are moving to medicine. So you mentioned process innovation, for example, and what you design remembers me of the assembly line of a car factory. So maybe it is important to visit other industries as well and learn them. And maybe you can use the Toyota methodology for quality management. Because there are classical principles and classical solutions. What is the innovation that you use it in medicine?
George, thank you for advertising for me, because I'm in operations management, and Peter actually told me about how important operations management is. Okay, now you can tell the story.
It really, yeah. Two comments responding to your comment. One is that what we also notice is that whereas best practices move fast from one industry to other for many reasons, healthcare lags behind. So when you already have, you mentioned Toyota, etc., all this is coming a bit later to healthcare. And just building on your exact example, one of our staff, one of our managers used to be an operations manager at General Motors. And this is one of the very, very big learnings, and I believe also success factors that we have abandoned the idea of having these superheroes who can do all in one. No, you have to shop the right capabilities at the right places.
Do you use a headhunter to get these people?
Less and less, I must say. So we go more and more, probably as advertising in the internet becomes simpler and simpler, and as also our brand is getting better known, we reach out to people through the internet, and they are also coming through us, to us. Very rarely we use headhunters, I must say, very rarely.
How did you finance your growth?
How did we finance our growth? In the beginning, we had a wealthy individual who was funding the business. At one stage, the business was taken to the Stockholm Stock Exchange. Then we found out that we were probably not, various reasons, but also we were probably not big enough for the stock exchange and didn't want to, the stress of quarterly reports and all the energy that you have to invest in that kind of stuff. So then was taken private again. And there's leverage as well. but we're being very conservative with our debt equity ratios, not over-leveraging the business.
Peter, maybe you could just briefly mention how the dental services finance.
Yes, and we also look for innovative ways of financing. And the reason Paul asked this question is because there is a program in Hungary which is called Jeremy, which is most of you probably know it. It is a European Investment Bank funded private equity money, and we use that money, for example, for our dental business.
Zsombor has a question.
John, sure.
I just have a comment to what Jörgen and you just discussed, is that, for example, there is, in cardiac surgery, there are mainly two procedures, like you either change a valve or you are doing a bypass surgery. And this is a quite expensive operation. And in India, they set up a hospital where more than 90 doctors are working simultaneously doing just these procedures. So this is really an assembly line hospital put together in India doing just this operation. And they have probably the highest number of patients in the world, and they provide the best outcome as well. And you may assume that they are very efficient because they pay low wages, but they don't. They pay quite well, their surgeons. The surgeons are working much like as robots or automats, doing the same thing again and again and again, but they earn a lot of money. They are proud of being probably the best ones in the world, and also they can provide this service less than half price than in the best US hospitals. So this is starting to move forward, but at least I'm an orthopedic, and in the surgical community of any kind of surgery, there's a very, very strong resistance to it. Everybody wants to do everything, and the older people are pushing the young ones to learn everything, and the young ones are aiming to learn everything, and it's an uphill battle. So I admire that Peter was just successful in pushing back all of these ambitions, and there is one very good measure to show that it works, that Medcover is growing, and most of those hospitals, probably all of them, which were created around a single great doctor, failed to grow. Just don't go deeper into that.
Yeah. It is also a very sensitive topic when you discuss it with doctors, obviously, and also when you discuss it with patients or potential patients, because most people have this image about the doctor as the cowboy or the hero, the most important thing. So of course we have to be. I'm much more direct here in my communication than I would be, with customers.
You are a company, so you have doctors and you have managers. Is there a power fight between doctors and managers?
No.
No?
No.
Different interests, different goals.
The way I say this is that everything is at the right place. So a medical director is part of the management team, and that person is a doctor. And then you have an operations manager who doesn't have a medical background, and you have a sales manager, and you have HR, and you have finance, etc., etc. And it is natural that everybody looks at things from her point of view. So just like you may have a different point of view by a finance guy and an HR guy, of course you have a different point of view from the medical guy, but not more than that. But we had to be very. And I really believe that this is one of our success factors, that we are sticking to the fact of having the right specialist at the right place. So the doctor is the medical director, and not the operations director, and not the HR director.
Okay, questions? Okay, good. Okay, Pierre, thank you. Okay, yes.
Just a comment to
30 seconds.
Yeah, okay. Just a comment to the presentation before that Google was not the first search engine. Microsoft didn't do the first graphical user interface. IBM didn't do the first personal computer.
Facebook is not the first social media.
Yes. So there are some other examples.
Yeah.
Sorry to contradict.
Yes. Yeah.
But we have to be a little careful with that.
No, you remember the first successful ones.
So you have to be the first in the customer's mind.
Well, I have here the first, for example, the first search engine, Alta Vista. I was the customer of that,
but still, Google is the first search engine in most customers' mind.
Okay, we can discuss that during the break. Okay, so there is now a free dinner available for everyone. So if you have questions or disputes, we can always resolve it over the dinner table. Okay, the free drink for everyone. So there is one, right?
Yes.
Oh, yeah, okay. Just to make sure.